Okay, so for our project, we decided to use the Open Flights Airlines dataset to put the airports as our vertexes and the routes to use as the edges between all the vertices. And for the graph, we decided to use weights, the distance between both airports. We went with the BFS traversal because we thought it'd be best for all the other algorithms we were using. We used Distra algorithm, which prints out the shortest path between multiple airlines, choosing one star airline. For the second function, we decided to use the BFS traversal to project onto a world map and with the tolerance.
Okay, so from Open Flights, we got the airports .dat dataset, which is a dataset of over 7,000 airports, containing a bunch of airport attributes, ranging from location to latitude, longitude. We parsed the airports dataset into airports.h. Airports.h is a single class which holds all of the different airports attributes. So we probably have about 7,000 airports objects when we parsed it. Then we have the routes.dat dataset, which takes in the three-letter code of the source airport, or gives the three-letter code of the source airport and the destination airport, and makes that the route that it's basically represents a flight directed in one. And two methods. We had load airports and load routes. So first we read airports.dat and we just parsed all of the airport attributes, and we constructed a new airport object, and we mapped the three-letter IATA code to that airport object, so that in order for easy access, because we knew routes would use the three-letter IATA code exclusively. That way we could get the latitude and longitude later. Then we used load routes. Load routes basically used a similar version to a vertex, source vertex, which was the three-letter IATA string, the destination vertex, which was the three-letter IATA destination, and an edge weight, which was the distance between these two airports. And we loaded that into the graph. So we had about around 3,257 edges and over 32,000 different flights in between those edges. So now Omar will explain Dijkstra's algorithm.
For the Dijkstra method, it basically calculates a shortest path. Given a start point and a graph, it calculates the distance to go to any other vertex on the graph. And it saves that, and just we made sure that we didn't loop through any node twice. And also we created a shortest path method, which prints out in a nice format like how to get to a certain place, which airports you'd have to travel through.
As my make is running, Bob can explain the BFS traversal.
Yeah. So for the BFS traversal, we implemented it like we kind of did in the past with an iterator. And doing that, we had to, add the constructor, the star operator, plus plus, not equals, and all that. And a lot of this was pretty simple. For the star, or the star, we just got the current value and like just basic constructors. For the plus plus is really where we put in most of the algorithm for the traversal. And pretty much what we did was we used a queue like a BFS does, and we added things to the queue and traversed in a way that was based on the edge weights, which we set earlier to be the distance. So we traverse things starting at O'Hare is our route because it's just a popular airport. That's a good place to start. And we traverse to the nearest airports first and kind of branch out from that with the breadth first traversal. And yes.
Okay, so I can run Dijkstra's here. It's a little slow. Basically, I'll run Dijkstra's and the BFS traversal here. So in Dijkstra's, we can enter the three-letter IATA of the source airport. So source airport for now we'll say O'Hare Airport, ORD, and then we can say we can say we want to go to, we can go to basically any airport. So let's say we want to go to an airport in Africa, in Niger. we can go to NIM, and it will say take a flight from ORD to YUL to NIM, and that'll be the flight. So it'll tell you the shortest path to get there based off the distance. Now I can say iterate, and this will show the BFS traversal as it iterates over 3,200 different airports. It only visits each vertex once, which shows that all of these airports are connected in this BFS traversal. And then now I'll talk about the last part while it's traversing. So basically, the last thing we did was the graphical projection. So we used the BFS traversal we just made and a tolerance. So what we did was basically we had the current airport, and we started and then we started at begin, and then we iterated through, and we projected each airport by using we kind of guessed and checked a latitude longitude to pixel converter. We kind of guessed and checked it by calculating our own x offset, y offset, x scale, and y scale, and we projected it onto a world map, and then we can use a minimum tolerance in order to project the edges as well. So say we would like only airports with over 80 different flights outgoing out of those airports to appear on our map. I can plug in 80, and then in graph.png, as it's running, but it was already ran before. In graph.png, the original image was a world map, and now we have only showing airports between that have over 80 outgoing flights. So basically the most popular airports, and these are all the routes. If I was to put in a tolerance of 0, which would take a little bit to run, but if I was to put in a tolerance of 0, almost the entire world would be covered. Here's 80. Before it was 120, but it's been changed a little. So, all right, now I will show. We can go over the tests.
Yeah, so to start out, we had to test the load airport data method we made earlier. And to do this, we pretty much just used the airport data, made sure that the graph we made was the right size, and that you could access the name and city of a specific airport based on the code in the graph. And that was pretty much it for the airport data.
So for Dijkstra, we tested it by testing the distance between the airports. We tested an invalid distance, which would return 0, a direct flight, which had distance of 1506, and then a multiple layover flight, which just calculated the distance between each path and like each airport in the path.
And then we also tested the BFS traversal, and pretty much what we did is we manually made this graph above with the weights and the vertices as shown, and made sure that it traverses correctly and that the traversal prints out the correct string when we go through the whole thing. So we're going to run our tests when the make file does its thing, and we can see what happens.
Yeah, but other than that, other than our tests running, sorry, it's slow. But other than that, that's our whole project. We basically just did it off the OpenFlight source, and we just had those 3 algorithms that we implemented. So we can just wait for the test to run. It's gonna be slow just because it's recording. So. We could probably just crop this out. I probably should have ran it like a long time ago.
Crop this part out and just say
there we go. Alright, so we're just gonna. Okay, so it took a while to run, but here we have showing that our test passed. Thank you for watching.